And we are back. This is going to be the second of 3 modeling lessons for the table lamp project. When I last left you, I was working on my diamond pattern 3/8 pitch serrations. All I did was the first 2 rows here, and then off camera I completed all the rest of them. So I'm done. I was able to get this done in 5 chamfer features, doing 2 rows at a time. And the pattern looks great. It's well balanced, it's symmetrical. The math works out for this perfectly. So now I'm ready to take a look at what I have to do on the back side or the bottom of the base on this side. So clicking back to this sketch, I have to add a through hole. This is a bored hole, so it would have a very smooth surface finish. This is to allow the spindle to insert into the base. It's showing a bore diameter of 0.8750 and underneath 0.8745. Now this is a machine shop boring tolerance. We don't need to worry about this when we create the extrusion. All we're going to do is just select 0.8750, but we are going to apply this tolerance to the drawing file. And there are a lot of tolerances on this particular project, and we're going to be using some new dimension features that we haven't seen before when we work on the drawing file. So for the purposes of working in Inventor, we're just going to pick the most nominal size and go with that. And this here, these 3 holes, they are on what is called a bolt circle diameter, right? It says here 3 holes equally spaced on a 2 3/4 diameter bolt circle. So we're going to include this bolt circle, but we're going to draw a construction circle. And lastly, we're going to be adding these holes. Now that is this note right here. This arrow points from here. It says drill 15/64, 1/4 inch ream, 1/2 inch deep. Okay, so what does that mean? Well, simply this is a counterbore hole. And I don't know if I've mentioned this recently, but I know I've mentioned it before, that a drilled hole in a piece of metal has a terrible surface finish. But you have to have a pilot hole drilled before you can ream a hole. So we're reaming with a 1/4 inch and we're reaming 1/2 inch deep. Now we're drilling 15/64, but it doesn't say anywhere on here how deep we're drilling. So we're going to have to specify a depth. So we're going to have to, that's something we're going to have to think about when we're doing the next process. But reamer. This is what a reamer looks like. And a reamer is a type of rotary cutting tool used in metalworking. Precision reamers are designed to enlarge the size of a previously formed hole by a small amount, but with a high degree of accuracy to leave smooth sides. So that is what a reamer looks like. How much material should be left for reaming? Very, very little. Look at this drill size, 15/64. If this was 16/64, that fraction would reduce all the way down to 1/4 inch. So we're leaving, after we drill this 15/64 hole, we're leaving 1/64 for reaming. A 64th is about roughly 15 thousandths of an inch, so that's going to be about 7.5 thousandths of an inch per side. And that's going to smooth that hole just enough to get that leg press fit into the bottom so this lamp can stand up on the 3 legs. So the legs are inserting into these reamed holes. There's a little theory behind machine shop reaming for you. Let's click into Inventor. Let's hit 2D Sketch. select this face, select circle, find X, Y, 0, 0, and we're going to draw this to be 0.8750, enter. Finish sketch, extrude, cut, all. Okay, now that was a breeze, right? We can take a look at this from this side, right? How this hole interacts with the diamond pattern. This should look symmetrical, up and down, left to right, and it does. It's dead middle because we started this hexagon right in the origin. The center of it passes right through X, Y, 0, 0. Let's flip to the back again, create another 2D sketch, and we're going to select construction. So push this down, and we're going to select circle. We're going at X, Y, 0, 0 again, and we're typing in 2 space 3/4, 2 3/4. Now this is going to give us our bolt circle. So we can't use a circle here because we're doing a reamed hole, which is a counter bore. That's another word for it. We're going to be selecting the point. We're going to be coming here and we're going to be selecting X 0, Y 1.375. So it found the coordinates, right? This is 1.375 is half of 2 3/4 on the Y value. So we're going to left click, add the point, and it doesn't go purple. It doesn't constrain. So I guess if you wanted to, you could just run a dimension like this, and that will cause it to constrain. And now we're going to hit the finish sketch, and we're going to go to hole. All right, so right now it defaults to a simple hole, which is not what we want, right? We don't want a clearance hole. We don't want a tapped hole. What we want is a counter bore hole. Seat. So we're going to select the counter bore. And we want this to be a termination. So don't select 2, don't select through all, but pick distance on termination here. All right, now we got to fill the parameters in. So I've already gone ahead and done this earlier. So this hole here, this is the hole that gets drilled with the drill bit. Its diameter is 15/64. That's what it says on the iPad image that I'm looking at. And its total depth from the top of the counter bore to the bottom, it doesn't include the drill point, by the way, right? So there's going to be a drill point because it makes sense that when you drill a hole, you're going to have a drill point left behind in your material. But we don't dimension from to the bottom of the point. We dimension to just above it here as this image shows you. So I picked 0.625. This is the same thing as, this is the decimal equivalent of 5/8. How did I come up with that number? Well, I know that the thickness of the base is 3/4 of an inch. I know that I have to ream a distance of 1/2 inch. So what does that leave me? That leaves me with 1/4 of an inch left. And the drilled hole has to run deeper than the reamed hole. So I've just naturally picked the center. I've picked the center depth between 1/2 inch and 3/4. So 1/4 inch divided by 2 is 1/8. I add 1/8 to 1/2 inch, I get 5/8. That's my mathematical reasoning. So that's the depth I'm going to select because there's no depth given on the sketch. So like I said before, we have to come up with something. This here, this is the depth of the reamed hole. I got the decimal values in right now, which is fine, but you know, we can change them to fractions. And then this is the diameter of the reamer that will come in and ream the hole. This is 1/4 inch. So I just input the fractions just to match what it says on the sketch. I could change the degrees on the drill point, but I'm not going to. It defaults to 118 degrees, and quite frankly, it's just not important to us to change the drill point angle. So once, and I'm getting a preview here, as you can see, right? We can see the reamed hole that's larger and the drilled hole here. So that's what that looks like, right? So the 15/64 hole, it drills from the top surface to this vertical line 5/8, and it leaves us with enough material. As you can see, the drill point, which drills deeper, is not going to interfere and break into any of those serrations that we completed earlier. So this is a totally perfect depth to choose. And then from the top surface to this vertical line is the larger 1/4-inch reamed hole. So that looks perfect and wonderful. So we're going to hit OK. It should have created hole 1 here. And there it is. And if you want, you can hit the free orbit and you can take a look inside. Right? This represents that drill angle point. This is the 15/64 finish, and this is the reamed diameter hole at 1/4-inch, 1/2 inch deep. All right, am I going to bother to do this 2 more times? Definitely not. I'm going to just create a circular pattern. This is going to be very simple. So the feature is hole number 1. Let's push feature down. Select hole 1, rotation axis, pick this bored hole right here. And then it's going to preview some reamed holes for you. Of course, we want 360 degrees, but we want to change the placement to 3 because these legs sit on the base like a tripod. And that's it. Hit OK, and we've got the other 2. Wonderful. All right. And that is where this lesson is going to end off for now. And the next time we speak, we'll be taking a look at the final lesson in the 3D solid modeling of the base, which can be a bit of a challenge in creating the concave radius that runs all around the perimeter. So that's going to introduce us to some new concepts that we have not seen yet. So lesson number 2 was kind of tame, but pretty easy. And when we next meet, we're going to be worrying about this concave milled profile. So until that time, take care and talk to you soon.